have no sound speakers today because when I turn them on, it sounds like this, which gets super annoying after an entire day. So no buttons today, no beeping countdown, but I assume that we are live. We're going to start PO22 today, which is going to be a two-parter. First, because we're going to talk about how to rewrite equations in two different forms. Slope-Intercept form, which you're comfortable with. You've dealt with that before. You've crafted it. We've looked at it already once this year. And what's called standard form. Okay. And the reason why we have two different forms is that depending on what you want to do with an equation, one form is going to be better than the other. If you want to graph an equation, slope-intercept form is the easiest way. It gives you the slope, gives you the y-intercept, gives you all that sort of stuff. If you want to continually plug values into an equation to see what the result is, that's what standard form is for. Okay. So slope-intercept form, we know what that is. Y equals mx plus b. Just write it down again, just because it's fun. In standard form, anyone know what standard form is of a linear equation? Real?
Do
you know? Oh, Noah's got the towels. Steele does.
Yeah. Thank you.
Yep. The standard form of a linear equation? Anybody? Standard form looks like this. It is ax plus by equals c. Ax plus by equals c. And notice that both forms had a b in them. In slope-intercept form, the b is lowercase. In standard form, the b is capitalized. That matters. These are not the same thing. Okay, just because something is b in slope-intercept form, it may not be the same b in standard form. But here's the thing about standard form. Here's why it's quirky. Standard form has no fractions and no decimals. A, B, and C must all be integers. They can be positive, they can be negative, but no fractions and no decimals, which is kind of a problem going from slope-intercept form, because in slope-intercept form, you often have a fraction. Slope is often written in fraction form. So one of the keys to going from slope-intercept form to standard form is eliminating that fraction. Okay, and that's actually the first step. This can go on a help sheet. It's a key point here. I recommend you put it there. Does anyone know how to undo a fraction or turn a fraction into an integer value? So let's take the fraction 3/2 here, and I'll write it over here. We'll write it again down below there. But if I have the fraction 3/2 and I want to eliminate the fraction, what I'm going to do is I'm going to multiply by 2. Now, why 2? What do you think? It won't always be 2. In this case, it's 2. Why do you think?
It's like the denominator.
Because of the denominator of the fraction. And when you multiply a fraction by its denominator, what happens? 3/2 times 2/1. Multiply the fractions. 3 times 2 is 6. 2 times 1 is 2. And what does 6 divided by 2 equal? 3, which happens to be the numerator of the original fraction, right? So essentially what you're doing by multiplying by 2 is you're canceling out the 2's, and what you're going to be left with is the numerator of the fraction 6 divided by 2 equals 3. Okay, so that's what we're going to be doing, and that's kind of the math behind the math there. Okay, so step 1 is to multiply each term by the denominator. I'm going to switch colors here because this is kind of important. Or the least common denominator, which can be abbreviated to be LCD. You've probably heard that acronym before. LCD, the least common denominator. And we'll do that least common denominator part when we have 2 fractions, like the third one here. This gets a little bit messy, right? I'm just going to warn you. But the first step is to multiply each term by the denominator or the LCD. Step 2, if you'll notice, another difference between slope-intercept and standard form. Slope-intercept, look at where x and y are, opposite sides. Standard form, they're on the same side. Okay? So once you eliminate the fraction, Then you want to move that x term over. Move x term over to the other side. And what method do we use whenever we move something from one side of an equation to the other? We can't just pick it up and put it there, right? We have to mathematically move it, and what method allows us to move it? Anyone else going, I like to move it in their head right now? That was just me? All right. What method do we use to move something from one side of the equation to the other? Yeah. Excellent. Using opposite operations. Yellow. Did I call? Oh, no. That would be theology. That I don't know. I think it is too. I don't see anyone across the hall. Okay, bye. Ooh, that was a serious phone call. Okay, using opposite operations. Okay. And that's it. Just 2 steps. So y equals 4x plus 7. There is no fraction in y equals 4x plus 7. So do we care about step 1?
No.
No. Beautiful thing. So we go straight to step 2. We say move the x term over to the other side using opposite operations. The x term is a positive 4x. What's the opposite of positive 4x? Negative 4x, right? So we're going to subtract 4x from both sides here. And the reason why I didn't write my minus 4x right beneath the y is because notice in standard form, x and y are separate terms, right? We can't combine them. One has an x variable, the other has a y variable. They're non-combinable. We have to keep them separate. So our final answer, we have a negative 4x plus y, because that didn't change, right? And then what's left on the right side? 7. And this is now in standard form. That was like a 9 now that I did that.
Is that it?
That's it. It gets a little more tricky when you've got a fraction, okay? But that's it for this example, right? Let's, everyone got the notes here? Are we all good? Okay. Let's scroll down and we'll do another one that's very similar to it. That y equals 12x plus 2. Go ahead and put that one into standard form. I'll rewrite the steps. What we did here, subtract 4x, negative 4x plus y equals 7. That was our final answer. Go ahead and put y equals 12x plus 2 in standard form. Not much is different from the example that we did together. Who's bold, brave, and wants to share what they came up with here? Oh, I thought we get some hands. Do we have to care about step 1 here? Are there any fractions? No. So we go straight to step 2, which is using opposite operations, move that x term over. What's the opposite of a positive 12x? Negative 12x, right? So subtract 12x from both sides, because on the right side, if you have 12x's, you take them away, now they're gone, right? Cancel out. And on the left side, we've moved those 12x's over. They're now negative 12x's on the left side with our y term, which we don't combine. And what's left on the right side is 2. Okay. Was this ever explained to you, this why when you move something over, you use opposite operations, and why having 12 x's on the right side, it keeps the equation the same if they're negative on the left side? Was that ever explained to you? Really? And like, okay. So let's say we have the equation 12 equals 7 plus 5, right? Can we all agree that that is a true equation?
Yeah.
Okay. Now, if I subtract 7 from both sides, and I'm going to keep them separate just to kind of show the point here. I'm not going to combine my 12 and the negative 7, even though I could. If I subtract 7 from both sides, what happens to the 7s here? Cancel out, right? I'm left with a 5. Okay. -7 and a positive 12. What's -7 plus 12? 5. It's still a true equation, right? Having a positive 7 on the right side, if I remove that and move it over to the left, it becomes negative because I've used opposite operations to do it. It's still a true equation. So that's why, kids, the biggest mistake that kids make here is they just pick the 12x up and they like put it over on the other side. And they'd say 12x plus y equals 2. Because if it's positive here, why would it not be positive over there? Well, it's not positive there because of opposite operations. When you move it over, if I kept this 7 positive, now all of a sudden the equation doesn't make any sense. 7 plus 12 is not 5, right? So when you move something over, the sign has to change because you're taking on the other side of the equal sign. So that's kind of what's going on here. That's why we, even though it's positive on the right side, it's negative on the left. Do the next one. Y equals -5x minus 3.
Which one?
Y equals -5x minus 3, the one in the middle there. We're still not tackling fractions just quite yet. And who is bold, brave, confident enough to share their answer? Nolan.
5x plus y equals -3.
Excellent. Positive 5x plus y equals -3. And the reason why?
Because opposite operations.
We have to add 5x this time because it's negative on the right side to start with. We're going to move it over. We're going to cancel it out. -5 plus 5 equals 0. It's now positive on the left side. We cannot combine it with the y to get like 6y or 6x or 5xy, anything like that. We have to keep them separate. And Nolan, nicely done here. Also keeping that negative sign with the 3. Okay, it belongs to the 3, and so on the right side we get -3. How are we doing? Okay. In the Mario world, we would call those like 1-1, right? Level 1 of World 1, kind of the most basic thing. Okay, they're only Goombas and turtles. Okay. Now we're going to start to add the jellyfish. You know what I'm talking about? Nope. They're called bloopers. Okay. Anyway, now we're going to talk about this fraction here. Okay, y equals 3/2 x minus 5, and we already discussed how to undo the fraction. But if you look at step 1 of your steps, it says multiply everything, each term, by the denominator. The denominator that we have here is 2, and so we're multiplying everything by 2. It's important you multiply everything by 2, otherwise the equation is going to become unbalanced. It's like if you're making mac and cheese, and you double the noodles and you double the cheese, but that's it. You don't double the milk or the butter or anything else that you put in there, right? It's going to taste different unless you double everything. That's what we have to do here. And like we explained earlier, multiplying 3/2 by 2, 3/2 times 2/1, gives us 6/2, which equals 3. Essentially, these 2's just cancel out, is what happens here, right? So y times 2 is 2y. 3/2 x times 2 equals 3x. The math is there to see. And then -5 times 2 gives us -10. The multiplying of the fractions is where folks tend to get lost. And so if you have a question, stop me now, please, and ask it.
So why is it a 2 in front?
Why is it in front of y?
Yeah.
Because if I double my 3/2 x and I double my -5, I have to double this too. Let's go back to our sample equation that we had. What was it? 12 equals 7 plus 5. Okay. If I were to double only my 7 and only my 5, well, 12 does not equal 14 plus 10. Right? What is 14 plus 10?
24.
24, okay? Which, if I double my 12 as well, now it's right. 24 does equal 14 plus 10. So if you double something in an equation or you triple it, or you divide it by 5. Whatever you do to one thing in an equation, you have to do the others as well. Okay? Otherwise, it's going to change it and make it an untrue statement. Okay? So, where the 2 came from? Because we multiplied y by 2. Okay? Anything else? That was a good question there. Anything else? Okay. Now we go to step 2, which is using opposite operations. Move that x term over to the other side. And so it becomes exactly what we did in these 3 here. Okay? We want that 3x over on the left. It's positive, so we subtract. 3x minus 3x is 0. On the left side, negative 3x plus 2y. Again, we can't combine them. Can't get negative 1xy or anything like that. Equals negative 10. And there's our final answer. Have I severely lost anybody? Okay, all right. You're super quiet today.
Locked in.
Are we all locked in? Word up. What up, brother? Let's go down to the y equals 4/5 x minus 3. Okay? Still dealing with only the one fraction. Step 1 says multiply everything by the denominator. What's the denominator of the fraction?
The numerator.
Huh?
I don't know.
What's the denominator of the fraction?
The denominator.
Yes, that means the number on the bottom.
Yeah, I know that.
What's the denominator of the fraction?
5.
5.
Oh. Yeah.
So what are we multiplying each term by? 5, right? Multiply y by 5, multiply 4/5 by 5, multiply negative 3 by 5. Everything gets multiplied by 5 because what we want to do, remember, is cancel out the fraction. Why does multiplying by 5 cancel out the fraction? Well, if we start with 4/5 and we multiply by 5, what's 4 times 5? 20. What's 5 times 1? 5. What's 20 divided by 5? 4. Okay? We eliminate the fraction by multiplying by the denominator. It really goes back to opposite operations, right? If we start with 4 and we're dividing by 5, we're essentially undoing that. We're multiplying by 5 to get back to 4 again. Okay? There's the math behind the math there. So multiply 4/5 by 5. We also multiplied our y by 5. That gives us 5y. Our coefficient to x is now 4. The math is there. That explains that. And then negative 3 times 5 is a negative 15. Where did the 15 come from? It came from the 3 times 5. Where the 5y come from? It came from the y times 5. And then the math for the 4x here is right here. Second step, what do we do?
I noticed it's on me. So, you know how, the numerator? It's
familiar.
always the x.
Yes, so no one's noticing here, and he's absolutely correct, that when you multiply by the denominator, your answer is going to be whatever the numerator was. Okay? It makes it, it was the same thing here. Multiplied by 2, we were left with 3. Multiplied by 5, left with 4. And the reason for that is because, if you multiply by the denominator, they essentially cancel out. Right? That's going to change a little bit, Nolan, when we introduce a second fraction. Okay? But that is the connection. We have a single fraction. It does just end up being the numerator. Nifty. What's our second step? Because we're not quite done yet. What does it say on your page? What do we do in all the other ones? William? We're going to subtract 4x from both sides. Opposite operations. Minus 4x, minus 4x. Don't try and combine the x and the y because you can't. Okay? So our final answer, negative 4x plus 5y equals negative 15. I did it again. That looks like a 9. I apologize for the lack of quality. There you are. Negative 4x. Questions? Okay, I'm gonna leave the work up here that we've done so far. I want you to try this one here. Don't be thrown off by the fact that it's a negative 2/7 x. The process doesn't change. You're still gonna multiply everything by the denominator. Just keep the negative sign with the numerator and it'll work out okay. Okay, but give that one a shot. We have the other two examples up here. See what you can do.
Wait, which one are we doing?
The one with the arrow pointing to.
Oh, yeah.
The arrow pointing.
All right, we'll erase the work and scroll up once people get a chance to do the thing. Okay,
I have it.
got it?
But the real number. Everything.
What?
You know, like, not just the drive, but I have everything.
Good. You follow directions.
Yeah.
Because it's great. Wow, proud of you. Good job. Okay. Let's see. I have to clear the ink. Sorry. If I can. There we go. Scroll up. Just so that people aren't confused, I'm still going to put an arrow to the one that we're working on there in case you get lost. Okay. What do you multiply by? What did you multiply every single term in the equation by?
Positive 7.
Positive 7. Okay. Could you do negative 7? Yes, it does kind of complicate things a little bit. So I recommend sticking with positive 7. So times 7, times 7, times 7. And why 7, Landon?
I said that.
I know that. I'm asking someone else. Welcome back, Colin. We missed you.
Because the denominator 7.
Right, because the denominator of the fraction is 7. Okay? And what's going on here is that if you take negative 2/7 and you multiply by 7 over 1, negative 2 times 7 is negative 14. 7 times 1 is 7. And not to keep you in suspense, but yellow. Okay, doke. Yeah, bye. The office has sent me on a little errand, and so I'm going to pause the video I'll be back shortly. Unfortunately, here we go. All right, so back to it here. Negative 2/7 times 7 over 1. Negative 2 times 7, negative 14. 7 times 1 is 7, and this simplifies down to be negative 2, which, as Nolan pointed out earlier, is once again the numerator of the original fraction. Okay, but that is going to become our coefficient to x, and so our equation y times 7 is 7y. We get negative 2x, and then 10 times 7 is 70. Okay, are we done?
No.
Well, first of all, sorry. Any questions on this?
No. No.
Okay, Gabby, are we done? No. What's our last step here? Penelope!
You have to let me check. Where we at? You have to
Oh, here. Wait, let me.
You have to move the equal thing. Make the equation. I don't know how to explain it.
You have to move the x term using opposite operations, right? So since it's negative 2x, we're going to add 2x to both sides. We're not going to get anything like 9y or 9x or 9xy or anything like that. We keep them separate. 2x plus 7y equals 70 because these on the right side cancel out. Nolan!
Can I go fill up my water?
You're already just diving in, huh? Is this your first or your second pass?
This is my first.
Can you wait the literal 10 minutes until you switch classes to do it? Because we're about to get to the harder part now. This was the easy part.
Okay, fine.
No. What if there are two fractions? There are
I'll
two
stay,
fractions.
How do you do two?
Two fractions. Okay? So, if there are two fractions, and let's go to this next one here, y equals 7/6 x minus 1/4. Okay? In your above directions, it says multiply each term by the denominator or the LCD. LCD stands for least common denominator, which essentially means what is the least common multiple of 6 and 4? Or, put another way, what's the smallest number that both 6 and 4 can go into? I don't say 2, because 2 goes into 6 and 4. What's the smallest
12.
number that 6 and 4 can go into?
12.
12. Okay? If you count by 6s, you count by 4s, 12 is the first number that shows up in both lists. Right? So, since the least common denominator is 12, that's what we're going to be multiplying our two fractions and our y term by. Okay? Gabby, did you catch that? This is where it gets a little bit tricky. This is important here, right? When you have those two fractions, you multiply everything by the least common denominator, which in this case is 12. So, I kind of wrote where I want to write here. We'll put the LCD over here. LCD is 12. So times 12, times 12, and times 12. Okay? And here's what happens with the fractions. Nolan, this is where what you noticed earlier doesn't apply anymore. Okay? Because when you take 7/6, I'm going to do the first fraction here, and you multiply by 12 over 1, what's 7 times 12? Someone with the quick maths here. 84. 6 times 1 is 6. What's 84 divided by 6?
8.
14. Not 7 anymore. Okay? Another way to do this, and I'll do this in red because you can do it either option, is if 84, 7 times 12, that's kind of a difficult multiplication. 84 divided by 6, not easy to do. Granted, you do have a calculator, but still. If you would rather write 12 as 6 times 2, because 6 times 2 equals 12, what does that allow us to do with these 6's here?
To cross multiply.
Nope.
Oh, cross something.
You cancel them out because we have a 6 in the numerator and a 6 in the denominator. If we cancel out the 6's, we're left with 7 times 2, which equals 14. Okay?
What?
Yeah. Nifty, isn't it? Like it's a little more complicated now. But if the red part doesn't make any sense, just multiply the fractions like we did earlier. Just know that you might get some larger numbers to work with. Okay? Now we go to our negative 1/4, and we are going to multiply by 12 over 1. Negative 1 times 12 is a negative 12. 4 times 1 is 4. And what's negative 12 divided by 4? Negative 3. Again, not the same numerator that we started with, but I'll do it in red again. What's another way we can write 12? That's going to help us here. 6 times 2 won't really help us here. What's another way to write 12 that will help us here?
4 times 3.
4 times 3. Nolan, why does 4 times 3 help us?
It's a gut hunch.
Gut hunch. Well, your gut hunch is right. Why does 4 times 3 help us?
Oh, because there's a 4 in the other fraction.
Right. Same reason why 6 times 2 helped us here. We canceled out the 6's, and we're left with 7 times 2 to get 14. Cancel out the 4's. Negative 1 times 3 is negative 3. Okay? If the red doesn't make any sense, it's okay. Multiply the fractions, you get the same answer anyway. But you see how this is a little more work than earlier? Now, we've got y times 12, which is 12y. Our x coefficient is that 14 there. our constant is this -3 here. And we're still not done. What do we got to do now? Oh, this is the easy part, though.
Oh yeah.
We did the hard part.
We have to move -3 to 3.
Not
Oh,
-3.
wait, you cross it out. Wait, cross out 14.
We have to subtract 14x from both sides, right? Yes. You said a lot of good things, Nolan. Okay. Again, can't combine the y and the x. Don't even try it. -14x, positive 12y equals -3. Now we're done.
We're done.
I'm gonna have to have the second page or something.
Second page is going the other way. Second page is going from standard form back to slope-intercept.
Oh.
We're not going to get there today.
So we just have 2 questions.
So, well, I mean,
Yeah.
I don't know if we're all ready to do a double fraction solo.
We're not.
No, we're
We're
not.
not.
We are.
We're
We
not.
are.
Too much
We're not.
Nolan,
Too much word.
Oh, yeah,
You
we're
have
not.
enough-
Actually,
you
we're
have
not.
enough
We're not. We're
You have
not.
So,
proof.
what I'm going to do, in the spirit of Christmas, is I'm going to give you what you need to multiply by to at least get you started. I want you to finish it, okay? In this first one, y equals, here, let me, Nolan, here you are. We didn't do that one.
Yeah, it is.
No, we didn't.
Or
No, we
you may
didn't.
have.
No, we
Oh.
What did you multiply by?
5.
didn't. Yeah, but I didn't do it.
With two fractions, you have to multiply by the least common denominator, which, Dominic, is what?
10.
It is 10. If you start counting by 5s and count by 10s, 10 is the smallest number, it's the first one that shows up in both lists. So, multiply by 10, multiply by 10, multiply by 10. I want you to take it from there. The very last one. 8 and 5, 2 fractions, multiplied by the LCD, the least common multiple. What do you think?
40.
40, right? If you start counting by 8s, count by 5s, 40 is the first number that shows up in both lists. So in this case, you're multiplying everything by 40. And after that, the process that we did together is the same, right? Give it a go. See what you can do. I believe in you. Okay, just these 2 for homework tomorrow. If you dramatically crash and burn, it's okay. Okay, it's okay. Give it a shot anyway. All right. That, folks, is how you math.
Don't forget to like it.
Thank you.